Hello, this is Mr. Collier, and today we're doing linear models and piecewise linear models. Okay, let's take a look at this first example. It's piecewise because it's like two different lines in one here. And this is about a mobile data plan where Colin gets 2 gigabytes. He pays 2 gigabytes, $2 per gigabyte, so that's the slope of this first line here. What's Colin's data allowance? So once he gets up to 10 gigabytes according to the graph, that's where it switches and he starts paying a higher rate because there's a higher slope here. So his data allowance is 10 gigabytes. Okay, at what rate is he charged for the excess data? Well, that's the slope here of the second part. And to get the slope, we're going to use the slope formula, but we need a couple of points here. It looks like clearly 2070 is a point, so we can get the slope from that. 70 minus 20 over 20 minus 10, which equals 50 over 10, or $5 per gigabyte. Okay, that's the rate he's charged after his data allowance is up. Okay, how much does Colin need to pay for 15 gigabytes of data? Okay, so let's take a look at how to do that. I guess we could just look at the graph here, because we have a graph. Here's 15 gigabytes, and it looks like about $45. So that's $45. Part D, create a equation to represent Colin's usage for the first 20 gigabytes. We'll need two equations, one for this one and one for this one. I don't know why we have to cut it off at 20 though, because it can keep going at the same rate after 20. But let's make the models. So let's write like this. So it's going to be piecewise. So use this big curly bracket. First section, we know the slope is 2 because it's $2 per gigabytes, and the y-intercept is 0. So it's 2x plus 0, or just leave it as 2x, and that works from x is 0 up until 10. Okay, now we need the equation for the second part, second line, and we have the slope already as 5. We can get the y-intercept by, well, let's set it up first. Y equals 5x plus b, the y-intercept. And then to get b, we can sub in a point. Let's sub in 10, 20. So 20 equals 5 times 10 plus b. 20 equals 50 plus b. B equals negative 30. So the second line is 5x minus 30. And that's for when x is greater than or equal to 10. Okay. Now let's look at part E. What data usage would result in a bill of $60? Okay. So if your bill is $60, looks like from the graph you'd be over here somewhere, right? So we're going to use the second line, second equation. So we're going to solve that. 60 equals 5x minus 30. Let's add 30 to both sides. 90 equals 5x. X equals 90 over 5, which equals 18, not $18. That's 18 gigabytes. Okay, next, let's look at what it means to be continuous. So if you can draw it on paper without lifting your pencil, it's a continuous function. So if you have an asymptote, a vertical asymptote, or a discontinuity here, they're not like connected, then it's not a continuous function. This one here is continuous because you can draw it without lifting your pencil off the paper. So let's take a look at this function. It says the function is continuous. Find the value of a. Well, the function is piecewise, and you get a different function up until 2, and you got another function when x is greater than or equal to 2. So 2 is the turning point where it goes from being a parabola to a line. So if the function was like this, it's not continuous. So they have to be connected here. Okay, the y value for the first part has to be the same as the y value for the second part at x equals 2. So that means 2 squared plus a has to be equal to 2 plus 5. So we have 4 plus a equals 7, and a equals 3. Okay, so you're going to have the function x squared plus 3, so it's going to start at 3. It's going to go up here, you're going to get to 7. Okay, that's 7, and then it's going to become a line after that. Okay, that's what the function looks like, and they're connected there because it's a continuous function. A continuous piecewise linear graph is constructed with the following equations, okay? By solving the equations simultaneously, find the point of intersection and hence state the value of A. Okay, so we set those equal to each other. Let's graph them and find the point of intersection. So we'll go to our functions app here. We'll graph 2x plus 1 and 4x minus 1. Okay, let's plot that, and we can find the point of intersection. Okay, it's 1, 3. So they meet at 1, 3. 1.1, 3 is there. One's got a y-intercept of 1. The other one's got a y-intercept of -1. So the graphs kind of look like this. But anyway, they meet at 1, 3. That's the important thing. That means that A equals 1. Okay, that's the point at which they meet. Okay, sketch the piecewise linear graph. Okay, let me just erase these here. And from a is less than or equal to 1, we're going to have 2x plus 1. So that's going to be this graph. And then the graph's going to change after that to 4x minus 1. It's going to have a steeper slope. Let's make a point. 1, 2, 3, 4. 1, 2, 3, 4. So it's going to be a bit steeper here. Okay, the green line's not so straight, but the blue line is steeper. Actually, let me fix that green line. Slope is 2, so I'm going to go down 2, right 1, down 2, right 1. So it looks more like that.